I think we should get going. Great. So, hello everyone. Great to see this many people wanting to join our session. Really excited. And welcome to our talk that is called Garbage In, Gospel Out, the Unrealistic Expectations of AI. And we hope that after these 45 minutes that you will be able to make more confident but also conscious decisions when starting AI projects in your daily works. So who are we that are standing here today? I would say that we are two AI enthusiasts that are trying at least to shape the future of society through technology. My name is Kejsi Gjordeni, and I have studied at KTH, Industrial Engineering and Management, with a specialization within computer science. And in Visma, I work as a business development manager. I have led a team of software developers within automation, but also working with business development and trying to find new areas within tech and mainly AI to grow in. And together with me, I have Rebecca.
Yes, so my name is Rebecca, and I'm also working at Visma, and I've been doing so since 2018. And during my career in Visma, I've been working as a data analyst manager, leading a team of data scientists and data analysts, as well as now, recently, I was appointed the position of product manager for our internal service called Visma Data Lake. As you hear of the name, data is what we are all about. And it's, of course, a really important building stone when it comes to AI. And I did my master's degree and engineering degree at the Uppsala University here in Sweden.
Good. And we would also like to spend a couple of minutes to talk about the company that we represent and come from. So we are from Visma, and I think that a big part of you might have heard about the company, and you might connect it to accounting software, or it's the logo that you see in your payslips, for example. And that is the truth, but it's also partly the truth because Visma is a big tech company and actually the Northern European leader when it comes to cloud ERP. So we are present in more than 150 locations. Our headquarters are in Oslo, Norway. And we have around 15,000 employees, and of those, around 6,500 work within software development. And we also see that within this big company, we have, I think, more than 1,000 different products. And what I think is very cool is that we can say that more than 75% of those are actually hosted on cloud. And as I mentioned previously, a part of the work that we try to do is also Visma's mission to shape the future of society through technology. And if you look at our customers, we have both businesses that can be as small as just one person, but also in some countries, national governments, which is pretty cool and also shows that with our software, we are actually influencing and driving the society forward. And one of the big areas within Visma is that we try to automate and also digitize business processes. Because we believe that through automation and digitization, we can both increase efficiency, but also create wealth in our society. So we do a lot of tech, we do a lot of AI, but we don't do AI in everything that we do because we don't think that it's necessary. AI has since many years been a buzzword, and we perhaps also used AI in our title to get you here today, and it seems like it worked. And it being a buzzword, we as tech companies are also sometimes pushed to market that we are doing AI, and this shows that we are trying to fit in by standing out, but everyone is doing the same. So in the end, we might end up in the same place. So what we want to talk about today is the pressure that we might feel sometimes to create gospel out of thin air, and perhaps to give you some tools on when AI could be the best solution and when not. And you might have heard this phrase sometimes, so can't we just use some AI? And I hope that after these 45 minutes that you will be able to have some arguments, but also a good answer to this question.
As Kejsi said, that AI is certainly a buzzword today, and it's a very broad concept. It can easily be misinterpreted, as well as we all, just in this room, probably have 50 different perceptions of what AI might be. And that's why we wanted to have this more general definition from the Oxford Dictionary, which say that the AI is the theory and the development of computer systems able to perform tasks normally requiring human intelligence. And that could example be visual perception, speech recognition, decision making, and translations between languages. And due to the fact that it is such a general concept today, is why it's so easy to use it in marketing without anyone really questioning if you're using AI or not. So with that, what is not AI then? Mainly, it's coded instructions with rules written by a human. So you can ask yourself if the task that you want to perform is simple enough for you to write a recipe for it, then you might as well write it in code instead. Or if you do not know how to code, you find someone who can translate that for you. An example of this would be like the smart plant pots that you've heard about. I looked into one of the main companies when it comes to smart plant pots, and they call it smart, and that might be true, but it's certainly not using AI. It is using sensors and pre-programmed rules to notify you if the soil is too dry, too wet, if it's too much sunshine, too little sunshine. And so it would be overkill to use AI because you can solve it in a simpler and cheaper way. So that's what you have to remember. Another case where AI might actually be a good solution is the Visma receipt scanning that we are offering in Visma. And this is a tool where you can scan your receipt and it digitalizes this receipt by finding the total sum and the tax, for example. I think there's even more features that it can pick up from this receipt. So you can imagine yourself, if you do not have AI, how would you solve this issue? How would you create a scanner of receipts by not using AI? So you would probably have to define, okay, you look at one receipt and you find, okay, which pixels contains the summation, which pixel contains the tax. And that's for that receipt. Then you have to go to the next receipt and the next receipt and the next receipt. And you can imagine that your code will be quite long in the end, and it's a very advanced software in the end. And how would you ever try to, do the debugging of this code? So here, AI is a great example because you could actually have the AI find those rules and learn those rules for you. We want to go through the history of artificial intelligence, because it's important to know that even though it's a buzzword today, it has been around for a long time. The first notion of machine intelligence was by Alan Turing in the 1950s in his paper that was called Computing Machinery and Intelligence. But in this paper, he did not mention artificial intelligence, but he certainly discussed around this idea of machines being as intelligent as a human being. The problem at this point was that the computer did not have the ability to store or memorize or remember what it had done previously, which meant that you could tell a computer what to do right now, but it didn't remember what it did the instruction before that. This changed, however, in 1949, and just a few years later, we could see the first AI being developed by guys named Newell, Shaw, and Simon. And this was the logic theorist, as they call it. The first AI here, it could actually write down detailed proofs or mathematical theorems. And it was so good, so it actually outperformed mathematicians at this point in time, human mathematicians. So that's really cool. It was this early that the first AI came to life. Just a year later, or the same year that they finished up this AI, the first conference and the concept of AI was actually formed, or like the discipline of artificial intelligence. And it was founded by McCarthy and his colleagues at the Dartmouth College during the summer research project on artificial intelligence. And these guys who developed the AI just the same year was actually attending this conference. And I think it was really funny when I heard Sarah talk earlier today in the first speech today. she mentioned this collective intelligence, and these guys did not manage to do this. McCarthy, he gathered like the top scientists in multiple fields because he wanted to discuss artificial intelligence and the theory of it and how it might look in the future. And then these practical guys came with their AI and wanting to show it off. But they did not listen to each other, which meant that these were the guys who developed AI was really frustrated because they were like, hey guys, we already did it, come on.
A typical AI or IT project.
Exactly. I mean, there's a lot of like that you can recognize yourself in this. So McCarthy actually declared that this like project was a failure because everyone had their own agenda and they just came and went as they liked. Unfortunately, because it probably could have, if they actually put their minds together, it could actually have been quite some interesting outcomes. During the next 30 years, there was quite a lot of development in AI, but there was one thing that was sort of holding it back, and that was the hardware technology at this time. Many of you probably heard about Moore's law. If you don't, I will briefly explain it to you. So it's the theory about how CPUs are growing in processing power, but shrinking in size. So it says that every 18th month, a microprocessor would double in the processing power, but reduce to the half the size during these 18 months. And then it would happen again 18 months later and so on. So during these 30 years, it actually become more and more, it become cheaper and easier to get a hold of these computers that had the processing power to put the AI theory into practice. And what happened then when the hardware technology caught up with the AI theory here is that we had the very famous Deep Blue AI by IBM beating the chess champion Kasparov in a game of chess. Now we are entering, or we have already entered, the era of big data. And this is why we have seen that AI can excel even further in the 2020s. So this is really cool. However, the Moore's law is coming to an end. We are hitting a wall here. And that's because now we're like reached the physical limit of how small a processor can be. And this means that we have to look to other hardware technology, like GPUs or FPGAs. So if you're interested in hardware, I definitely recommend you to look into these hardware technologies because it's really cool and definitely the future of computing, not just AI, but computing is cool. Now, on to our AI evaluation loop.
Yes, exactly. So now we've spent a couple of minutes trying to explain what AI is and what it's not, but also give you a brief history lesson on AI technologies and how they emerged. And the rest of the time we want to spend on the most fun and also interesting part. It's this AI evaluation loop or framework that we've created. And it's basically 5 steps or 5 questions that we believe are the ones that you should ask yourself prior to starting an AI project. And this shouldn't be done once, but it's the questions should be repeated again and again. And also it's not a one-man show. So the decisions shouldn't be made by one person alone, but rather a group of interdisciplinary people and so
collective thinking.
Collective thinking, that's true. So I think we can dig into the first step.
Yes, so the first phase here in your project would be the pre-project phase, where you have a use case and you have to determine, is this suitable to use AI for this use case or not? And to do that, I have written, draw here the scale of complexity. So we'll start on the left-hand side here with, if you have something that is simple enough to do without AI, don't use AI because it's going to be overkill. It's going to cost you more money than you have to, and then it has to cost. And simple enough would be like the plant pot that we mentioned. So if you are able to have these predefined rules, go for that. That's going to save you a lot of hassle and time. However, if you realize that this pattern or the task that you want to do is way too complex for you to write it down by hand, you might be at the other end of this complexity scale, where the patterns are too complex and it's determined by thousands and thousands of parameters. For example, stock market is super difficult to predict because it's so many parameters affecting the price of a stock. And for example, if I would like to have an AI cleaning my house, that is like super broad. So what do you want it to do? Do you want it to clean the floors or the windows, or what are you expecting? Well, here you can break it down. So you can, you can have one AI doing one piece of the puzzle, or maybe it's not AI in, AI doing the whole task. It could be a smaller task within that task. So once you have broke it down and found maybe that sweet spot of a clear pattern, not necessarily a simple pattern, but a clear pattern, it's a specific task with limited number of output options. This doesn't mean that you can't predict numerical values. That's not what I'm saying. But here that it's not about like cleaning the windows and the floors, right? It's just a limited number of outputs. So here, AI might give you great results. You are ready to move on to data collection. So do you have enough, and do you have enough good data available for your use case? Here we created this QQBB, funny, how to say, acronym, maybe. So quantity first. The amount of data has, as I said, for a long time been difficulties in building good AIs, but finally we are in the era of big data, and we have this data available for most cases. So here you have to make sure that you have enough data to do this. And you can think of data as an experience in a human being. So the more you've seen, the more you've experienced, the easier it is for you to make a good decision, to make a good prediction. So since you have your experience from today, you can actually predict what's going to happen tomorrow, because you have that knowledge. The same it is for AI and data. So data is the AI's experience. The more data the AI has seen, the easier it is for it to make an accurate prediction of the future. A great example of this is the research that has been done a lot now in the latest couple of years on diagnosing breast cancer using AI. And it was actually used to the AI was trained using 5.4 million images. That's a lot of data, especially when it comes to image recognition in this case. And if you can imagine being a doctor and going through 5.4 million images and not just looking at them briefly, you actually have to decide, does this woman have breast cancer or not? You have that, responsibility. So it's going to take you a lifetime to get through these images. So this AI could do it in a matter of days, right? It could gain all this experience. And it actually outperformed a few cases, at least, not in all cases that I've seen, but in a few, it actually outperforms doctors. So awesome. You have a great quantity, so now you want to move on to quality. Do you have a good quality in your data? So maybe you have outliers in your data that is not representing the whole group, but it's actually outliers. Or maybe you have missing information in some features. Or maybe you are missing labels and you want to use supervised machine learning. Let's say you want to predict or be able to identify cats in a picture. Then you have to make sure that you have labeled those images with cat or not cat for the AI to understand if it's a cat or not. I know that Kejsi has a good example of this quality issue that you happen upon.
Yeah, so in one of our Visma products, we have a very good chat support function. So a lot of customers are using it, and we have many years of collected chats. And we thought, okay, can't we just use some AI? Let's see what we can make out of those chats. And however, these chats weren't labeled in a certain category. So we thought, okay, can we perhaps use unsupervised learning, try to find some clusters? However, all of the chats were predicted to the others category, meaning they were too similar and the data was quite imbalanced. And if we had labeled these chats previously, then we would have been able to perhaps do some supervised learning on it. But that's also quite easy to think about after. So that was, I think, a good example of having a lot of quantity, but not the best quality, and also the imbalance issue.
Exactly. And here I can also go back to the cat example again. If you would only show the AI pictures of cats, it will have a hard time understanding when you have a picture of something else than a cat, right? And that's, you can see yourself. If you are a kid and you've only seen cats your whole life and then suddenly you see a dog, would you know that it's a dog? Would you think that that's a cat too? And then finally we have bias, so a really trendy topic. And that's due to its importance. So it's like, it's fair. It should be a trendy topic. Here it touches upon both data and the use case. So the data can cause biases, but I would say it's the use case that determine the ethical justifiableness of this AI. Something to really keep in mind. And the data will most likely always have a bias. I mean, that's sort of also what you would want in a way, because you need to know the patterns of tomorrow to decide the future. And those biases is probably in there somewhere. But then you have to make sure that if you're going to use this in production, that you make sure it's ethically justifiable. And you have, for example, if you in HR, you've tried multiple times to use AI, but it's sort of tend to always go back to, is this actually ethical enough, or could we defend this using this AI, because it actually turns out to be a bit biased, maybe towards like hiring men before women. I mean, if you look at the number of CEOs today that are men compared to women, and then you expect an AI to train on this data and not be biased. Well, we've been biased for 100 years, so how can we expect that the AI would be different? I mean, there's really a true sense of garbage in, gospel out. Of course, it's going to be garbage out if you send in this biased data, right? So back to our loop. Now we have entered the stage 3 here. Maybe you've gone back and forth here a bit, hopefully in evaluating both data and the use case. So now it's time to execute this. So do you have the right skills, and do you have the right tools to create this AI? Here it's when it comes to skills, you definitely need to pose the right questions to make sure that you know that what you're asking for is a good question to be answered by an AI. We have, for example, the chatbot experience, the example that Kejsi mentioned, where the question would be not to let the AI classify all these texts, because that's very general. You need to rather pose it as, if I have a chat text and I want the AI to put a category on this one. But what category does this text belong to? And then when you have that question, then you can actually choose the proper algorithm. And if you're not a data scientist yourself, and you haven't involved someone already who knows the topic, here's when you definitely have to do that. That can help you find the right algorithm for the question. And then it's also a lot that can go wrong when applying the algorithm. You have the causes of underfitting or overfitting at this stage. There's a lot to think about here. When it comes to tools, I have some experience myself. You have to use like up-to-date tools and libraries. And I was working on a churn prediction project when I began at Visma. And what I happened upon was that I had to use C# to program this ML model, machine learning model, because that's what they use in their application. So fair enough, I'm going to go with C#, even though it was not preferred by myself. However, it turned out that there was a bug in this library, because C# is not very commonly used within data science. At least it was not a couple of years ago. And that meant that the libraries was not checked regularly. And it was a bug that made I couldn't decide how many decision trees I wanted in my machine learning model. It was always 10. So you can imagine the frustration when I tried to, fine-tune these variables, and I couldn't change the number of trees. It didn't happen. Nothing happened when I changed the variable for number of trees. So I was really glad when I found the bug. But what if I didn't? Maybe I couldn't have used that machine learning model after. So make sure that you're using up-to-date tools and libraries. And here I can definitely recommend using Python if you want to do data science, because that's used by Google and many other big players, as well as it is used a lot by the community, which means that you have both community and professionals that are working and updating these libraries as with the newest feature or findings, as well as debugging them. Then you also have to think about the performance. We talked about this in the history of AI, how difficult it was. So here you make sure that, do you have enough power on my own laptop, or do you have to go to like a cloud solution? Maybe I need to set up some virtual machines to be able to perform the way that I need to. And then plan for scalability. So even if it works on your laptop today, maybe that's not what you want to do forever, right? So how would it look like if you want to put this in production? Kejsi will mention this a bit later also, how important it is to think about this when you're starting your AI project also. Like, is this something that you want to scale? How would that look like? And that's over to you.
Yes, thank you, Rebecca. So now you went through the 3 phases, and hopefully the answer to those questions has been yes. And now we come to the 4th stage, where you are actually trying to go to production and also scale your idea. And the question rises, is this case financially viable? Of course, innovation and playing with AI and learning is very important. And in Visma as well, we are investing a lot in innovation. We have even started initiatives trying to promote innovation in our companies that have been around for years to get these new ideas. However, it was mentioned earlier today as well that innovation needs to grow in the state of status quo. That means that we can't expect to have these real business effects if our idea can't be anchored in a business case. So here it's very important to involve both people from strategic areas in your company and also the business areas together with the tech specialists to try and create this great new idea. Because what we see is that in the discovery phase, which we've gone through, you can iterate your idea and 10 and 20 times over at the same cost as one time in delivery stage. And we see that the cost of change actually increases exponentially. So this is something that is very important to keep in mind, to also try and test before you go into production. And to also have in mind what the business plan is going forward. How many customers will you be having? How many users will be using your AI feature? Yes.
It's so much cheaper to iterate here than to iterate over there.
Good. So when you've went through those 4 stages, and this is probably done beforehand. So all of the 4 stages that we've gone through is something that you can answer before even starting when you are in the idea phase. However, we have the last one, which is retrospective, and that is very, very important when you've actually deployed your AI solution. Because even though you succeed with everything, the only or the most important metric is if it's being used, if it's creating the value it was intended to do when the idea came up. So then you have to answer the question, was AI the best solution for the use case? And this, as I mentioned, is something you can't answer beforehand. But when you answer it after you've deployed your solution, it's important to not only ask yourself this question once. So you will do it once, and that's after implementation. So is the solution actually delivering on minimum performance? And here it's important that you've set that. So what is minimum performance? What are those success criteria? Because if you don't have that baseline, then you can't answer the question if it was successful or not. But then it's very important to actually come after, let's say 3 or 4 months after implementation, to really see if the solution is actually being used. And here I also have a real life example from Visma where my team, we took over a solution that was developed by another team. And what we see is that, okay, this model hasn't been used, and we didn't have any input or output for months. So we were investing quite some money in keeping this up and running. However, it wasn't being used. And then it might be because it wasn't good enough. It might be because the users didn't know how to interact with it. But what is important here is to actually monitor. And we also saw this with the Microsoft chatbot that was deployed on Twitter. I don't know when exactly, but
a few years ago.
Yeah, a few years ago. And we saw that just 24 hours after deployment, it went quite crazy and actually started writing racist things. And if we don't monitor our solution, that might happen. It's an extreme case, but it could go quite wrong. So ask yourself, is the solution actually being used? But then after some more time, also ask yourself, are you investing in the solution? Was it that good or that important that you are putting in resources, money, time, and also new technology to keeping it up to date and also improving it? So if you answer yes to all of these 3 questions during this longer period of time, then yes, AI was probably the best solution for your use case.
And that is our AI evaluation loop. So even though they are named like retrospective and pre-project, it's definitely good to go through them before you're starting the project. Everything should happen in the pre-project phase, and then you can go back to to these stages and also look at maybe AI projects that you already developed. Where did it fail, or why did it fail? It probably in either one of these steps. So, Kejsi, can't we just use some AI?
Well, I have to go through the AI evaluation loop first, I think. Yeah, so what we wanted to tell or try to display for you today is that it's very simple to ask the question. However, to answer it, it's quite complicated, and you might be put on the spot to try to defend to your manager or to your organization why we can't just use some AI. But then we hope that these supporting questions and evaluation steps that you can go through might help you in giving a very well-grounded and supported answer to the quite difficult question, I would say.
Yeah. So thank you so much for listening, and we have time for questions if there are any.
Yes.
I have a question about what can be a good minimal performance? How do you sort of set that?
Yeah. I don't know if you have a good answer.
I was both you have like the AI model in itself, like looking at the accuracy, the area under the curve, what is it living up to those technical measures that you've done, but you also have like the business perspective if you look at that.
Yeah, but I also think it depends a bit on the question. Like, so for breast cancer, it's quite important that you actually categorize it correctly. So depending on the area and the question, it depends.
But then, yeah, and also like the business KPIs, like if you have a pressure on making a certain amount of revenue on this model, you have to follow up on those. So that could also be a part of it, like setting those business values, minimum performance. Yeah. Yeah. So just to repeat the question as well, if not everyone heard, was like how do you differentiate AI to deep neural networks or other like machine learning techniques? And that is basically that AI is a superset of machine learning. So we are using AI in a broad concept today as well, where we could have also changed some of it, which I also did, like using machine learning instead. And so those, I would say, like you mentioned, is techniques, and they are all within like the concept of AI, and that you can use those to create AI in a way. Yeah. Would that explain? Yeah.
But that's also a very important question, because there isn't a clear. We took up the formal definition of AI, but if you Google and go to different sources, it might differ. So that's also important to keep in mind.
Yes.
How do you find the processes there where you want to implement the AI?
Oh, can you clarify? What do you mean? How would you find?
It's not always like somebody's coming up and saying, I can use AI on this, so you actively working on it. What are the processes that you could implement?
And so just to repeat the question, that you're asking then, like, how do we find in the business where are these processes where we can actually utilize AI? Like, how do we find those cases?
Yeah, and as we do today, for example, in my automation team where we also work with AI, it's mainly looking at those departments that are where you mostly find these repetitive manual tasks. So it could be everything from the finance departments to HR, payroll, and so you spot, okay, where are the people that are working today having the most struggles, and then we look into if AI could be a good fit for it. However, I don't think that going directly to AI is the good approach, but look at the problem and then see what is the best possible solution, and AI might be the best possible solution.
You have to start at the problems.
Exactly.
And find those problems first. Yeah. And then see, like, is AI a good technique or tool? Any more questions? Yeah. So the question is if the developers in our teams you find it difficult or fun to work with AI, or maybe both. Do you want to take that one, Kejsi?
I hope they believe it's fun. At least that's the feedback that we get. And we have a lot of different development teams in Visma working within different areas. And what we see is that we give quite large room to grow and learn new techniques and technologies. So yeah, it's difficult for me to answer since I don't work as a developer, but
yeah, I've been working a little bit, I would say, at least as a more data science part of it, and the data scientists that are in my team definitely like it when we can find those complex problems, right? But they do understand when it's about the business as well, that we cannot just go and do some AI, right? So it's definitely to find that balance in a way also, and where they feel comfortable and where they are challenged, because that's when you have the most fun, that you can sort of revert back to your comfort zone if you need to, but you also have those projects that are really, really challenging, because that is what makes you grow in the end.
yeah, and I would go back to is it the case financially viable? That's also a quite difficult discussion to have sometimes, we need to run a business, it needs to keep on going, but also we want to innovate and give people room to grow and learn new things and try and fail. So yeah. Yes.
So the question is if we can replace, in the future, if programmers will be replaced by AIs. And yeah, I mean, it's of course difficult to predict that, but it's definitely an option. But here again, it would be if there's specific coding tasks. So it depends on your question, right? And what you ask the AI to perform. I think there already are actually cases where you can ask an AI, can you write a function for me that does this? Great, then it's going to do that. But you cannot ask the AI, can you write the code for a scanning app, or can you create a chatbot for me? You know, that's more complex, and I have to break it down to smaller tasks. But that, I think, definitely, and as I said, there already are AIs that can do those. So the question is when we can build those, put them together. And yeah, maybe, who knows?
Yeah, but it will be very interesting to see how that field grows, because we have, for example, GPT-3 now, where you can just ask it, okay, can you write a poem for me? And then it takes all this big data and translates it into a possible poem, for example. But yeah, I think...
And you have AIs that can write, they can write fake news as well as identify fake news. So that's also, of course, a cool field. Yeah.
My question was actually, can you give an example of areas here that we cannot definitely use any AI? I don't know, maybe.
So you started off by saying it was a really good comment here that the AI is always processing this old information. So of course you have you can implement self-learning for that. It always produces take into account more data, but also learns from what it predicted. So what did I do a correct prediction or not? But it's a bit more advanced AIs. And then your question was, is there any fields that we can see that this is definitely not AI friendly, or that here you wouldn't? I don't know if it was be able to use AI or if it was doesn't fit. Yeah, should. Yeah. Not be able, it's too complex. I think that's that we shouldn't say that, because that's going to be the case where internet is a bubble and will go away. That type of clip, right? If we try to say that.
True. Okay.
Yeah.
Yeah. No comment.
Yeah, exactly. It probably are. There are areas today that we don't have the technology to do it. But to say that it never will be that's I wouldn't dare to do.
Yeah. But I think when you look at there are some areas perhaps that we should use AI as a support tool, but perhaps not let it make the actual decisions. For example, in perhaps hiring or, it depends. It could be more objective if you feed it with unbiased data, for example. Yeah. But a good question. We'll see.
So the question here is how does Visma work with customers' data and since the customer is actually owning their own data, and that's really important to think about when going into projects as well. Where does your we didn't talk about that, but like the ethics behind data collection, right? And I think that we have to look at from two perspectives. So we both have like product development, and this is where you could actually you have the opportunity depending on what deal you have with the customer. But if you can improve the product using their data, then it's usually okay. That's usually where the line can go. So if you're working with product development and want to leverage the customer's data into creating a better application for that customer, then that could be okay to do, usually. But then also you have to differentiate between customers' data and data about our customers. And that is kind of an interesting also, like from a legal perspective, what's okay and not okay to do. So if we have customers sending invoices, we are definitely not allowed to process the information in that invoice for our business cases and trying to leverage upsells and so on from the information in that invoice. However, we can use that the customer sent an invoice, the metadata of it sending an invoice. That we can know and that we can look at in trends and identify if there are bottlenecks in our processes and whatnot to improve. So that's definitely where legal and data analysts has to work together to understand like where are the limits and not to cross them if we because then you could definitely reach out to a customer if you have a really, really great idea and like this would be so cool to do. And I bet that we have done that in Visma. I haven't, but maybe we have.
Yeah, I can't come off one example, but I think that we can also like anonymize the data. So there are certain tricks that we could do to get more amount of data. We should have someone from legal.
Yeah, exactly.
Taking this question. Yeah. Yes.
Because it's a lot of things in Twitter and the internet and whole, but why it picks up the baddest things. Yeah.
So the question was why we think that bots like the AI bots on Twitter, for example, that Microsoft created and they let out on Twitter, and it was turned very quickly into racist and anti-Semitic AI, and why we would think that happens. And at least my thought would be that is what's being promoted on social media. And that's like if you get many likes, many shares, that's what's triggering, and maybe that's what they put in. I don't know. This would be just my guess that it's the data and it's like reinforcing that this was a good tweet because you got a lot of shares or a lot of likes on it. And social media is known to feed the extremist opinions here, and that could be the case. I don't know if you have any other.
Yeah, but I guess it also reflects the reality on social media and Twitter. So it picks up, as you say, both the things that are being promoted and most reaction given on, but that's also the content that is out there.
It would be really interesting to discuss. We can take one last question.
Yeah.
So in the future, do we think that AI can be dangerous? I think it already is.
Yes.
Yeah. Thank you so much.
Thank you.